Hello, and thank you for joining me for today's program. My name is Brian Carpenter, and I'm a professor in the Department of Psychological and Brain Sciences at Washington University in St. Louis, where I've been doing research on Alzheimer's disease for over 20 years now. Today, I'm looking forward to a conversation with you about where the scientific field stands today and our growing but still insufficient knowledge about this disease. So to set the stage, let's begin with some basic cell biology. And apologies to those of you who were biology majors or pre-med in college. To begin with, the healthy adult brain has about 100 million neurons in its cells in the brain that have long branching extensions called axons and dendrites. And these branches are pathways that connect neurons to each other and enable them to communicate with each other via chemical and electrical signals. The chemical elements of this communication system are called neurotransmitters, chemicals that are released between the gaps in neurons called synapses. In ways that we still don't understand, this incredibly efficient and technically elegant electrochemical system is the foundation for all of our memories, our thoughts, sensations, emotions, movements, and skills. So pause for a moment and consider all that this marvel of your brain has enabled you to do so far today. Maybe you put on your favorite shirt, and you could do all of that with steps that required very, very little thought on your part. You mostly did it without thinking, and more deeply, you know that you have a shirt and what makes it your favorite. Or maybe you enjoyed a cup of coffee or a mug of tea, or ate something that was sweet or salty or sour or crunchy or slippery. And you could eat all of those things, mostly without effort or thinking, because of your brain. And your brain lets you experience all of those sensations. And maybe you listened to the news or read a book or saw a painting or smelled a lilac or planned a trip or felt awe at the sunrise or told a lie or said to someone, "I love you." Thank your brain for all of that. And now imagine what your life would be like if you gradually, over years, lost the ability to do those things. That your memories, thoughts, sensations, emotions, and even the most basic movements were gradually lost. That's the journey that people face when they have Alzheimer's disease and some other types of dementia. Now, just use the word dementia. So let me explain what that term means. You've probably heard the word dementia before. It comes from the Latin meaning out of mind. And it's a general term that scientists and medical professionals use to describe a whole set of different diseases with common symptoms. Alzheimer's dementia is the most common type of dementia, but it's only one type of dementia, and there are many others. And we're starting to understand the connections and differences between these different types of dementia. Some types of dementia are caused by changes in the brain that lead to a set of symptoms that are irreversible and often progressive. These are what we call the primary dementias, such as Alzheimer's disease. Other types of dementia, by contrast, look similar in terms of their symptoms, but have a cause that can sometimes be reversed with proper treatment. These are the secondary dementias. For instance, a deficiency in vitamin B12 can lead to symptoms that look like dementia, but that can be reversed when normal levels of that nutrient are restored. So when physicians are evaluating a person for possible dementia, they investigate these and other treatable causes. Now, as I mentioned, Alzheimer's dementia is the most common cause of dementia. Here, I'm also using some terminology very intentionally. Notice that I'm using the word Alzheimer's dementia and not Alzheimer's disease. That's because as scientists have learned more about what's going on in the brain, they've come to understand that there are specific changes happening in the brain that are characteristic of Alzheimer's disease and different than other diseases. So those changes in the brain are referred to as Alzheimer's disease. And when those changes in the brain become widespread and severe enough, symptoms appear. People have problems with their memory and their thinking. And when those changes appear, the person is said to have Alzheimer's dementia. the syndrome of the changes that we see. So Alzheimer's disease is the neuropathological change that leads to Alzheimer's dementia. You'll also notice that I lost an apostrophe in there. I'm not calling it Alzheimer's disease, which is what you might hear about more commonly. No longer Alzheimer's disease, but now just Alzheimer's disease and Alzheimer's dementia. This is part of a trend that's happening throughout the medical field for other eponymously named diseases. And for the grammar purists out there among you, this change is happening because Alzheimer, the person who discovered the disease, the changes that are happening in the brain, he never owned nor had the disease himself. And so with that little bit of nerdy trivia, you can loud it over your friends at the next cocktail party. And I'm going to use the abbreviation AD to stand for both Alzheimer's disease and Alzheimer's dementia. And I'll be talking about those in different kinds of contexts throughout the talk. But for simplicity, I'm just going to refer to them both by the abbreviation AD. Okay, so back to our story. Unless you've been living in a cave or on the moon, I don't need to tell you that Alzheimer's dementia is a major public health issue. Large number of Americans are thought to have this disease. It's a major cause of death among older adults. When individuals have this type of dementia, they often need assistance from family members and friends and other paid or formal caregivers. So it's not just the person with the dementia who's involved. And this is a disease that has tremendous financial implications for our society, major public health issue. In the last 2 decades, with a combination of medical and public health interventions, we've been able to make some amazing progress at reducing the risk of dying of certain diseases in the US. This graph shows the change in the percentage of people dying from breast cancer, prostate cancer, heart disease, and stroke, and HIV. And in the United States from 2000 to 2019. And they're all decreasing either pretty dramatically or if they're going up very, very slightly and much less rapidly than they were before in the case of breast cancer and prostate cancer. So we've made progress in many diseases at reducing the extent to which these are causes of death in the US. But that hasn't been the case for Alzheimer's, where we've seen a steady increase in the number of people dying with Alzheimer's disease, Alzheimer's dementia. And the projections for the future, barring some miraculous discovery, look equally grim, as you can see in this figure, with the increasing prevalence rates forecast for the decades ahead. You can locate your state on this map and see what kind of increase in Alzheimer's dementia is predicted where you live. The increase varies from state to state, mainly because of the average age of the population in each state. The greatest risk factor for Alzheimer's dementia is advancing age. So states that have older populations are going to experience more people with Alzheimer's dementia in the years ahead. But these statistics, while jarring from a public health point of view and a social point of view, don't tell us much about the personal pain and challenge that individuals and their families experience with AD. And I want us to consider that behind all of those statistics are the stories of very real people, individuals whose lives are upended by this terrible disease. And those are the stories. That's the reason we should be concerned about those statistics. So I started by giving you a little bit of background on biology. Now it's time for a little early history. Symptoms of dementia have been found in written records in human societies for thousands of years, dating back to early Egypt. But dementia, as a diagnostic term, was coined only in the mid-19th century, first arriving to describe a disease that was called dementia paralytica. This was due to the progression of syphilis, which led to changes in memory and thinking at its later stages. Diagnosis and treatment were limited then. There weren't any techniques available to examine the brain microscopically, so scientists weren't really sure what was going on and causing the dementia. And so instead, causes were thought to be associated with immoral behaviors, excessive drinking, sexual promiscuity. And it wasn't until the late 19th century, with the arrival of the microscope, that scientists had the ability to see changes going on in the brain, which prompted a shift in our understanding of the causes of dementia. Alzheimer's disease gained its name from Alois Alzheimer, a German psychiatrist who studied with Emil Kraepelin, the foremost psychiatrist in Europe at the time, and the person most responsible for trying to bring some sort of scientific rigor and categorization system for psychiatric disorders. Later in his training, Alzheimer joined Kraepelin to work in his clinic in Munich, where he developed his skills in not only caring for patients, but also examining tissue samples using this new technique called photomicroscopy. In addition to a research scientist, though, Alzheimer was also a practicing physician. And in 1901, he began treating a German housewife named Auguste Deter, who experienced a precipitous decline in her cognitive functioning and her overall functioning, much more difficult for her to take care of herself, beginning in her early 50s. Her symptoms weren't that unusual from those that you would see in people in their 70s and their 80s. But because her symptoms started at such a young age, Alzheimer was very interested in studying her, and he did so very carefully, keeping detailed observations and notes on his case over many years. Ms. Deter died in 1906 due to an infection, and Alzheimer examined her brain using these new techniques, and Alzheimer saw what has become the core features of AD: amyloid plaques and neurofibrillary tangles inside the neurons of her brain, and the death of neurons in certain parts of the brain. And I'll talk about those two characteristic features in a moment. Alzheimer himself wasn't really sure whether Deter's symptoms were due to the same cause as the cognitive and functional decline that you saw in people in their 70s and their 80s, which was referred to at the time as senile dementia. But in 1910, in the first edition of Kraepelin's textbook, Clinical Psychiatry, Kraepelin did use the term Alzheimer disease and gave the name of Alzheimer to this disease for the first time. Interest in the disease then waned during the early 20th century, primarily due to the World War, where the world's attention shifted from the laboratory to the war effort for obvious reasons. But attention to it gradually came back after the wars were over and people were living longer and more people were developing Alzheimer's dementia, raising its visibility and concern among scientists and public health officials. So I said that Alzheimer used these new techniques in microscopy, along with the new techniques in cellular staining, to identify the changes in Deter's brain that are characteristic of Alzheimer's disease. So what is it that's actually changing in the brain of people with this disease? Well, there are two changes going on at the cellular level identified by Alzheimer and prominent in the brain of people with AD. The first is the accumulation of an insoluble protein between neurons called beta amyloid. As beta amyloid aggregates and accumulates in the intracellular spaces, it clumps together and creates what are referred to as plaques. And those plaques interfere with the ability of neurons to communicate with each other. So that's one of the changes that's going on. The second change in the brain involves the accumulation of another protein within neurons called tau. In healthy brains, tau helps stabilize other structures in the brain called microtubules. And these are important in a cell's ability to move nutrients around and into and out of the cell, removing waste products, bringing nutrients in. But in Alzheimer's disease, tau sticks to other molecules, forming threads that join to form neurofibrillary tangles inside neurons, and that block and disrupt this transport system that the cell relies on. These changes within and between neurons eventually lead to the death of these cells in certain parts of the brain. The most common locations of cell death occur in the hippocampus. That's the area of the brain that's important for the formation and the integration of memories. The amygdala, which plays a role in emotional expression and comprehension, and the cerebral cortex, the front part of our brain that's responsible for complex higher order cognition, things like reasoning, planning, judgment, and insight. And as cells in those regions of our brain die, cognitive functions also begin to deteriorate because of those brain regions deteriorating. As an example, here are some brain scans that show images highlighting the differences in the hippocampus, one area that's important in memory function. You can see a smaller hippocampus that occurs normally with aging, but accelerated in the case of mild cognitive impairment, which could be a precursor for AD, and in the case of AD itself. In fact, we observe a decrease in overall brain volume throughout the brain as AD progresses. In parallel to these structural changes are functional changes in the brain, how the brain is operating. This is an image of a positron emission tomography, or a PET scan, which measures glucose metabolism in the brain. Brighter colors indicate higher levels of glucose metabolism as the brain is working. And you can see more blues and fewer reds and greens in the brain of this individual with Alzheimer's disease, suggesting less brain activity overall, a consequence, again, of those deteriorating and dying neurons. So that's what's going on in the brain. But how are these changes reflected in what's going on with our thinking? What's going on in the mind as these changes are happening to cells and tissues? One way that we can help evaluate a person to determine how their thinking is changing because of their brain changes is through a psychological procedure known as neuropsychological testing, a series of paper and pencil, and these days more often computer-based tests that are used to measure a range of cognitive functions. Different patterns of performance in attention, memory, visual spatial functioning, language functions, executive functions, which are our higher order functions, and also changes in mood and behavior. They can tell us something about what might be going on in an individual's brain, what has changed over time, what might be different from what we would expect based on a person's age, race, sex, or educational background, and might also give us information about what might be causing those changes in their thinking. As examples of what this might look like in actual practice, to test language function, we might ask people to name as many words as they can that begin with a certain letter in a minute. Or to examine memory, we might ask them to repeat a series of words they're given and then recall them after some time has passed. And to test their concentration and arithmetic skills, we might ask them to count backwards to see how quickly and accurately they can do that. Other tests involve visual and drawing functions, which tell us something not only about a person's motor skills, that is, can their brain still tell their hands what to do, but also their ability to plan, sequence, and remember. For instance, we might ask them to draw a figure that looks like this one. That might look pretty simple, but for a person with AD, it can be challenging to recreate this figure, as you can see in this drawing from a 69-year-old man with moderate AD. You can tell he still has a sense of what the shapes look like, but he has difficulty with translating that into an accurate reproduction. Another common test asks individuals to draw the face of a clock. The instructions are, I would like you to draw a clock, put in all the numbers, and set the hands for 10 after 11. Again, that would seem like a pretty easy task for most people, but when you think about it, it does require the ability to pay attention to the instructions, to remember those instructions, execute the task, and plan out the placement of numbers, hands, and set those hands correctly. Instructions which could be easy to mess up, particularly if you were having any difficulty with your cognition. So consider this attempt from an 85-year-old man with mild to moderate AD. What does this drawing tell you about his visual spatial construction abilities and his planning abilities? These are the kinds of differences and deviations from usual performance that we're looking for on these kinds of tests. Or this drawing from an 83-year-old man with severe AD. Neuropsychological tests are typically used in combination with blood tests, brain scans, and sometimes other tests to come to a best guess about whether an individual has dementia and what kind they have, since the pattern of performance across these tests looks different depending upon the type of dementia. Now, as our science in this field has expanded, so too has the way that we've defined and diagnosed AD. In 1984, for example, the disease was diagnosed based on its clinical symptoms, including changes in memory and other cognitive abilities that patients or family members reported or that we could observe on neuropsychological tests. Laboratory tests, on the other hand, were, as you can see in this definition, largely used to rule out other causes of the person's symptoms. But thinking about this has changed in recent years, moving away from the clinical symptoms to focus instead on the neuropathological changes in the brain. And here is the definition that came out in 2018 from a combined working group from the National Institute on Aging and the Alzheimer's Association. They revised their diagnostic information, shifting the focus onto the biological changes rather than the clinical syndrome. In that new framework, people are diagnosed with Alzheimer's disease based on the presence of amyloid plaques plus the presence of tau tangles. If people don't have those two hallmark changes in their brains, then they are presumed not to have Alzheimer's disease, but may have a different disease instead if they're experiencing changes in their cognition. That change in the diagnostic framework came about largely because we've come to understand that changes in the brain start happening years, if not decades, before there are any observable changes in a person's memory or thinking. This figure shows the hypothetical progression of changes, with beta amyloid starting to appear in the brain maybe 20 to 22 years before symptoms. Tau tangles showing up again, perhaps decades before symptoms. And as they accumulate, it's only then that brain atrophy begins, maybe around 13 years before symptoms. And finally, early memory changes arrive, followed by worsening memory and changes in other functions. So currently, scientists believe that people can be in a state called preclinical Alzheimer's disease. And in this phase, individuals have measurable changes in their brain that indicate the earliest signs of Alzheimer's disease, but they have not yet developed symptoms such as memory loss. And again, people may have these signs of changes in their brain 10, 20 years before they experience any symptoms. These kinds of biological markers or biomarkers include abnormal levels of beta amyloid observable both by PET scans in the brain and through cerebrospinal fluid, and decreased metabolism of glucose that's also observable on PET scans. But the important thing to note here is that Alzheimer's disease begins well before Alzheimer's dementia, which is when symptoms are apparent. We've also come to understand that there are other changes associated with AD, including the ones that you can see on this list. In fact, some scientists have proposed that AD may in fact be a collection of different diseases and processes that eventually lead to cognitive impairment. When those brain changes accumulate over time, it's possible that an individual may begin to show symptoms, to notice changes in their memory thinking, at which point they might be referred to as having mild cognitive impairment due to Alzheimer's disease. As the brain changes progresses, early mild symptoms may become more noticeable by the people themselves or by people around them. These aren't major changes in memory or thinking. They might not be noticeable or may be very, very subtle. And typically they don't interfere with an individual's ability to carry out everyday activities. People are still able to go to work, drive, do their everyday life without much difficulty at all. However, among about 15% of people with MCI, they will go on to develop a full-blown dementia within 2 years. And 32% of the people with MCI will go on to develop a full-blown dementia within 5 years. But I want to emphasize that not everyone with these mild cognitive impairment go on to develop dementia. And some people actually return to their baseline functioning, particularly if the cause of their dementia is reversible, such as those that are due to vitamin deficiency. But that doesn't stop people from being very worried as they grow older when they experience changes in their memory and their thinking. You may have experienced some of these things yourself and wondered whether they're the beginning of signs of something like Alzheimer. It's important to understand, though, that almost everyone is going to experience some changes with their memory and their thinking as they grow older. And the things you see listed here are common for most people because their older brain is different than their younger brain. Just like their older kidney is different than their younger kidney, their older lungs are different than their younger lungs, their older skin is different than their younger skin. That doesn't necessarily mean that they have a disease like AD. Alzheimer's dementia is not a normal part of aging. If you're going to take one thing away from our conversation today, that's it. Alzheimer's dementia is not a normal part of aging. It is a disease, and not everyone gets it as they grow older. So here are some of the changes in cognition that many people experience as a part of normal aging, and changes that are more severe and could be indicators of AD or another type of dementia. And here are a few more as well. So you should be hearing in this story that the neuropathology of Alzheimer's disease is imprecise, that a large number of people who start to develop changes in their brain may even start to have mild symptoms, do not go on to develop AD. That some proportion of people who begin to have symptoms actually revert, become better, return to their baseline. And frustrating to scientists, a fairly large number of people will have signs of changes in their brain, amyloid, tau that's present, but yet they will not experience symptoms. And a large number of people who are diagnosed because they have symptoms, when you look at their brain under a microscope, they will not have the quantity or the density of amyloid and tau tangles that you would associate with AD. So these biomarkers turn out to be imprecise indicators of whether a person will develop a frank dementia, or whether, if they have clinical symptoms, whether their brain will reflect what we expect to see. This is one of the mysteries about Alzheimer's disease that we're still trying to figure out. We do know with some certainty, though, that the vast majority of people who develop AD are age 65 or older, the vast majority of them. Experts believe that AD, like other chronic diseases, develop as a result of multiple factors that accumulate as we grow older rather than a single cause. And the greatest risk factors for AD are older age and having a family history of AD. A family history of AD is not necessary for an individual to develop the disease. However, individuals who have a parent or a sibling with AD are more likely to develop the disease than those who don't. And people who have more than one close relative are even higher risk. Family risk may also be due to shared environmental factors, such as access to healthy food, inherited habits around exercise, and so on. Among these other non-modifiable risk factors, gender is another prominent one. About 2/3 of women, 2/3 of Americans with AD are women, as opposed to 1/3 who are men. And the prevailing explanation seems to be that first, women outlive men, so they have the opportunity to live longer to develop dementia. But it also might be due to unequal distribution of other risk factors, such as lower average education in women. There are other risk factors, however, that are modifiable, something we can do something about. Some scientists suggest, in fact, that if we were able to address these modifiable risk factors for dementia, we might prevent or delay as many as 40% of cases of AD. Now, as I mentioned, one of the most significant risk factors for AD is age. Back in 1910, when Alzheimer and Kraepelin were publishing their work, only about 4% of the US population was over age 65. But because of expanding life expectancy in the last 100 years, people are living longer, and they in turn develop more neurodegenerative changes in their brains, and therefore are more more at risk for developing cognitive decline and dementia. You can see that reflected in these statistics, that the prevalence of AD increases with age. But I'll also point out that at age 85, only a third of people have Alzheimer's dementia, which means 2/3 of the people at that age do not have Alzheimer's dementia, echoing something I said earlier, that AD is not inevitable as people grow older. Another risk factor that I mentioned is genetic, and here again, genetics are not destiny. The genetic risk for AD primarily comes in the form of 3 forms of the apolipoprotein E gene, or APOE gene. There are 3 forms or alleles of this gene, E2, E3, and E4, and everyone inherits 1 form of this gene from each parent, resulting in 6 possible combinations. Now, these different combinations of this gene are associated with different degrees of risk for AD. Turns out that the presence of the E2 and the E3 allele appear to be protective against AD. It's the A4 allele that's the risky one, with 1 copy of the allele increasing a person's risk of developing AD by 3 times, and 2 copies increasing a person's risk by 8 to 12 times. But even having the E4 allele doesn't mean that a person will develop AD with certainty. Recent research suggests that individuals with ApoE4 gene have a decreased risk of developing dementia if they've had more early life education, had mentally challenging work over their lifespan, participated in leisure and exercise activities, and had strong social networks later in life. So again, age, gender, race, genes, they do not preordain that an individual will necessarily get Alzheimer's disease or Alzheimer's dementia, even if they are prominent risk factors. And I mentioned race as well. This increased prevalence in minority populations is, again, probably not due to genetic or underlying biological factors, but instead due to health disparities, things that we could address as a society. When symptoms do become more severe, dementia due to Alzheimer's disease can occur. And this happens when there is biomarker evidence of Alzheimer-related brain changes, along with noticeable and more severe changes in memory, thinking, and behavioral symptoms that interfere with a person's ability to do their everyday functions. In the mild stage of AD, most people are able to function without difficulty or help in many areas, but they may require assistance with some activities to maximize their independence and remain safe. They still may be able to drive, although they may restrict their driving range or the times at which they drive. They still may be able to work, but with more limited responsibilities, and they can participate in their favorite activities. But they may need help with more complex activities. As AD progresses, symptoms change and generally worsen with time, reflecting an advancing neurological damage in different parts of the brain. The pace of these changes, however, is very difficult to predict for any one person. This is one of the other mysteries of Alzheimer's disease, that we can't be sure how quickly the disease is going to work in any one individual, or what pattern of symptoms we might see emerge in that individual. The moderate stage is often the longest stage, in which individuals may have worsening difficulties with communication and performing daily tasks for themselves, such as getting dressed or taking a bath or a shower. This is a phase that can unfold over many years. Individuals may not be able to sequence the steps that they need to follow in order to complete a task, or they might leave out steps altogether. And eventually they stop doing these things for themselves at all, without any unless they have prompting or assistance. They might also be incontinent at times at the later stages of the moderate phase, and start to have personality and behavior changes, including uncharacteristic anger, suspiciousness, paranoia, restlessness, or agitation. And finally, in the severe stage, the final stage of AD, people need help with almost all of their activities and may need 24-hour care. Because of damage to areas of the brain involved in movement, individuals often become bedbound, which makes them vulnerable to blood clots, skin infections, and other kinds of infections. Damage to areas of the brain that control swallowing make it difficult to eat and drink without choking. Food and liquid may end up in the lungs and cause infection and pneumonia, which is a major cause of death among people with AD. On average, people live between 4 and 8 years after they receive a diagnosis before they die, although some live as long as 20 years. So this is a long journey living with this disease. Sometimes we hear about AD when we learn about celebrities or other famous like these folks who had AD. But unless we have personal experience with a family member or a friend with AD, it's hard to imagine what the experience is actually like. To give you a glimpse into the process of change, consider William Ottermolen, an American figurative artist who was born in Philadelphia, who attended art school in Philly and then in England, and had a career that took him back and forth between countries for many years. In 1991, Ottermolen began experiencing changes in his memory, and he was eventually diagnosed with Alzheimer dementia in 1995, at which point he began a series of self-portraits that he painted until 2001. And in these self-portraits, you can get a sense of the gradual decline in cognitive functions, and perhaps also a gradual decline in a sense of self that Ottermolen experienced, as do most people as their disease progresses. So what is well characterized is the gradual loss of memory, changes in personality, disruptions in mood that unfolds over many years. But what's not known, as I said, is the trajectory that any one individual will face. When, if at all, their symptoms may emerge, how quickly they'll develop, and what pattern of changes will be specific to that person. Nor do we know why some individuals have good days when their orientation and their memory are relatively clear, and why they eventually slip back into their losses. So many mysteries remain about the clinical side of this disease, but also the personal experience of living with dementia. Of course, AD is challenging to the individual with the disease in so many ways: loss of cognitive abilities, loss of independence. But let's take a turn for a moment to consider the impact of dementia on the people who take care of them. And by that, I mean mainly family members and friends who provide the bulk of the care that are needed by people with dementia. Given the long, progressive, and ultimately severely debilitating nature of AD, you can imagine the implications for caregivers in terms of their own mental health, physical health, finances, and the impact on their other relationships. Most of these caregivers are women, typically wives, daughters-in-laws, and they fulfill a wide range of needs. Caring for a person with AD is a career that unfolds over a very long period of time with many stressors and challenges, but also opportunities for uplifts and joys for caregivers who can navigate the terrain with support. There are many effective interventions and ways to support caregivers, including support groups, education programs, counseling, respite care to give people a break, and case management. And all of these are important tools for caregivers to rely on to help them through their own journey. Prevalence statistics about AD may be a vast underestimate of the actual number of people with the disease, because so many people are never evaluated or given a diagnosis. So those are huge numbers that I showed you earlier. Imagine that those are just an underestimate, the tip of the iceberg of this problem. One reason is that people may not report changes in their thinking or functioning to their doctor because they're natural. They believe they're natural, an unavoidable part of aging, and therefore they don't warrant evaluation. That message is reinforced by birthday cards like this one that I found that convince people that failing memory is an inevitable part of growing older and therefore doesn't indicate anything wrong, anything they should mention, anything that they should be taking steps to do something about. Another reason why AD may be underdetected is that physicians may not talk with their patients about cognitive problems or investigate them, even though the Medicare annual wellness visit that all Medicare recipients are entitled to can include annual cognitive screening. You should be asking your doctor for that cognitive screening if it's not offered to you. Primary care physicians will tell you that it's important. They think it's important. They know it's important to do these kinds of evaluations, but under 50% of them actually routinely do. So advocate for yourself and ask for this when you need it. There is no single test that your primary care physician or neurologist is going to offer you for Alzheimer's dementia, but providers use several different kinds of information. Obtaining a medical and family history from the patient, including a psychiatric history and history of cognitive and behavioral changes, conducting some neuropsychological tests or cognitive screening, having the individual undergo some blood tests or brain imaging to rule out other potential causes of dementia symptoms, and in some situations using brain scans like a PET image or a cerebrospinal fluid tap to determine whether there are higher levels of those abnormal proteins. Initially, scientists believed that if they could replace some of the neurotransmitters that were declining in people with AD, they could restore functioning. And that's been the focus of the 5 medications that have been approved by the FDA to treat AD. Note that the last one here, memantine, was approved in 2003. Here we are in 2022. The last medication approved for Alzheimer's disease until recently was in 2003. And until just last year, there had been no other treatments approved, despite the huge number of scientists investigating treatments and the huge amount of money spent on trials that went nowhere. None of the drug treatments that are available today for AD slow or stop the damage or destruction of neurons that cause Alzheimer's symptoms. With the exception of memantine, the remaining drugs temporarily improve some cognitive symptoms for some people by increasing the amount of neurotransmitters in the brain. But the effectiveness of these drugs varies widely from person to person, and they wane over months. In addition, they have overall general limited clinical utility because they don't modify the underlying disease. They have significant side effects. They're relatively expensive, and the majority of people in the population see no improvement with these drugs. Now, at the turn of the century, scientists began moving away from treatments that focused exclusively on those neurotransmitters. And attention has more recently turned to amyloid and tau themselves, those 2 proteins, disruptive proteins in the brain. The hope with these treatments is to delay the progression of the disease or perhaps even reverse it. Even an incremental delay in the onset of symptoms would be significant, not only for people with the disease and their caregivers, but also for the healthcare system in terms of saved costs. However, since the early 2000s, there have been more than 400 clinical trials of therapeutics for AD, most of them targeting the clearing of this amyloid protein, and all of them have failed, 100% failure rate. Some studies have used a vaccine-like approach to try to clear the brain of amyloid, but none of these trials have been effective, with several treatments demonstrating a high risk of swelling or bleeding in the brain in enough patients for those trials to be halted. Now, you may have heard in the news last year about a new medication, aducanumab, also called Aduhelm, from a company called Biogen. This drug is an anti-amyloid antibody. It's a form of immunotherapy that works by triggering the brain to clear amyloid. But that drug has not been without controversy, and as you may have read in the news. In 2019, aducanumab failed what's known as a futility analysis, and Biogen said that they'd halted development of the drug because of unpromising results. But somewhat miraculously and somewhat suspiciously, months later, the company said that they had taken another look at the data and they revived it. There were some encouraging outcomes related to cognitive and functional loss, but also some worrisome microscopic hemorrhages and brain swelling that happened for some patients. Currently, despite pressure from the manufacturer and from the Alzheimer's Association, and because of advocacy from scientists who were familiar with Biogen's research and had concerns about the data, The FDA has approved aducanumab, but for only very limited use with patients in clinical trials. So it's still not clear that this new medication will be the innovation that everyone is hoping for. But that's not to be too pessimistic, because despite the limitations of current drug treatments, there are drug and non-pharmacological interventions that are effective at addressing the symptoms of AD. There are medications to help people with their mood and behaviors. There are behavioral interventions to reduce agitation, wandering, and help people improve their memory. And there are ways that we can adjust the environment and the community in which people live to help support people and maximize their independence. One example is the Village of Hope that's currently being planned in Clearfield, Pennsylvania. This development is one of the many that are emerging within what's called the dementia-friendly community movement. And in this case, the development is taking a decommissioned school property and its surrounding 23 acres to create a community that will be open to people of all ages and all cognitive function, and will be designed to support them in their needs. So people with cognitive changes, people with dementia will be welcome in this community, as are adults with disabilities, grandparents raising grandchildren, families, single individuals. The hope is to create a multi-generational community that will support people across the lifespan, regardless of their cognitive and physical limitations. This development is one of many that's emerging. And you can see several different research studies that are pointing in the direction of multi-pronged interventions to target brain health. We're starting to understand that one way of addressing AD may be to look more broadly at brain health as a way of preventing or forestalling the onset of symptoms. Several clinical trials recently, including the FINGER study in Europe, which used multiple components, have yielded some important preliminary findings about delaying the onset of cognitive disabilities. Here in the US, they're running a similar study called the US Pointer Study that's currently accepting people into their study. It also uses a multi-pronged lifestyle and behavioral intervention approach to target some of the risk factors associated with cognitive impairment. And these are actually strategies that are unfolding around the world as well. All of them tend to take a multi-pronged focus, targeting several different aspects of our behavior and our lifestyle that appear to be placing people at risk for developing cognitive impairment. And doing the right things in these different areas may be protective for our brains. Here's an example, for instance, about the recommendations regarding physical activity. These are interventions and recommendations that are not telling people they need to go out and run marathons or do heavy weightlifting. You can see here that the recommendations regarding exercise are relatively modest, but appear, based on the science, to have positive effects on people's cognitive functioning. And here are some of the guidelines focused on nutrition and our diet. Again, these are not dramatic changes. In fact, they may be things that you already know about. The challenge is spreading this information more widely, making sure opportunities for things like physical exercise and good nutrition and healthy foods are available more widely in the population. So there are some positive signs on the horizon that as we're learning more about how to keep your brain healthy, the byproduct of that is that we might be able to develop interventions, population-based interventions, to affect cognitive health, brain health in our entire population, which is likely to yield benefits down the road, to create better brains when people are younger, stronger brains, and to reduce some of the risk factors that place people at risk for developing cognitive impairment and AD. I do want to close by just mentioning a couple of caveats, though, because there are other interventions in the marketplace that require people to do a little bit more research and to approach with a little bit more skepticism. Many people are taking a wide variety of supplements these days that are designed, or at least purported, to provide some benefit to people's brain health. These are supplements that include vitamins, minerals, amino acids, botanicals, including herbs and enzymes. They come in many formulations: pills, capsules, tablets, powders, food bars, liquids. And in a recent survey that AARP did, a large percentage of people over age 50 said they were taking at least 3 supplements every day. And about a fifth of those people said they were taking them to improve their brain health. Now, most people don't know that the Food and Drug Administration, these supplements are not going before the FDA to evaluate their safety and their effectiveness. And so these supplements are not allowed to make claims regarding their ability to treat a disease such as AD. But those are guidelines that are only enforced when people bring a challenge for a product to the FDA. And recently, the Global Council on Brain Health did a review of the current science on brain health supplements and discovered that currently there's insufficient information to suggest that any of these products that are available in your local pharmacy or a grocery store are necessarily doing anything that's very healthy for your brain. Another intervention that's gotten a lot of press lately is cognitive training. There are several companies that are providing online or other forms of brain exercises or brain training. Here again, the science is relatively new and hasn't always been very sound, although this may have some promising effects on cognitive health in the long term. However, the research tends to be very, very early in its infancy. And there was another consensus statement that came out recently that focused on the brain training industry. So here again, when you hear advertisements for supplements, herbs, medicinals, brain training, cognitive exercises, there may be something to some of these, but this is a situation where the consumer needs to be very, very well informed and to stay up with the science to tell us what we think is actually beneficial for improving people's cognition. So there are some good developments on the horizon. We've learned a lot in the last 50 years regarding the connection between some basic behaviors, but we're still learning day by day about how a disease like Alzheimer's unfolds in the brain, what might be responsible for its development. And unfortunately, we're still a ways off to finding a cure or effective treatment. And for the moment, attention at these population-based interventions, things that we can be doing every day to take care of our health overall, seems to be the most effective way of bolstering your brain and making sure that you've got a strong brain as you're moving into the later years of your life. Thanks for joining me for this first segment. I'm looking forward to our conversation ahead and your questions. Hello, everyone, and thank you for joining us for the program. And thanks for the excellent questions that have been coming in so far. Lots of good, thoughtful, insightful questions. So let me start out by talking a little bit about the diagnostic process. We had a couple of questions about what that process might involve and what it looks like. And one of the very good questions is whether it's possible to actually see these amyloid plaques and neurofibrillary tangles in a living human being. And unfortunately, we can only see the substances that might tell us that those plaques and tangles are present. It's impossible to measure those things in a live person without taking a piece of tissue from the brain. And most people need their brains, and so we try not to take any sort of living tissue from them if possible. So there is no such thing as a living brain biopsy where we can see the neurofibrillary tangles from the tau protein and the amyloid deposition, the amyloid plaques from the beta amyloid deposition. But we do have other ways of detecting signs that beta amyloid and neurofibrillary tangles are accumulating. So, for example, one of the scans that is particularly useful is the PET scan. And the PET scan can tell us information about how the brain is metabolizing glucose. So if your brain is working, it's metabolizing glucose. And if we see declines or decreases in the rates of metabolism in particular parts of the brain where we know plaques and tangles do their worst work, that's one indication that there may be something going on in the brain that's responsible for those changes, and it's likely to be plaques and tangles associated with Alzheimer's disease. Another indicator shows up in the cerebrospinal fluid. So you can get a lumbar puncture. For any of those who had a lumbar puncture before, it's inserting a needle directly into the spinal cord to measure substances within that cerebrospinal fluid. And one of the substances that's detectable within the CSF is amyloid proteins. So it's possible for us to see elevated levels of those proteins by using a lumbar puncture. You may have also heard that in the last year or so, the FDA has approved a new blood test that can detect some of these biomarker changes as well. This blood test is a simple blood test. You can get it at your doctor's office. It's been approved and it's not reimbursed currently by insurance. So not a lot of physicians are asking for it or prescribing it because it's pretty expensive. But as you can imagine, it's much less invasive and much less expensive than getting a PET scan or getting a lumbar puncture. So some people are suggesting that this blood test is going to be a game changer because it's going to make diagnosis much, much more accessible, which will be a good thing if it allows us to detect changes in people earlier. The downside, of course, is that we may end up diagnosing a lot of people who have biomarker positive evidence of changes like amyloid deposition and tau deposition that for some people will go on to develop Alzheimer's dementia, but for some people won't. So the dilemma is going to be for the consumer is, do you want this test if it indicates that you may be at elevated risk for developing Alzheimer's dementia, but we can't tell you if for certain you're going to, we can't tell you when it might happen, and we can't tell you for sure that despite our best efforts at keeping your information private, that somebody couldn't get their hands on that information and use it against you in an employment setting, if you're applying for long-term care insurance. Now, of course, all those things are illegal to use your health information to discriminate against people in employment or health insurance, but, those things can happen. So this blood test, promises to be a game changer to a certain extent, but still a lot that we don't know about how it's going to be used in practice. So someone else asked whether a diagnosis of Alzheimer's disease and dementia can be definitive while a person's still alive. And technically, people have probable Alzheimer's dementia until they're dead, at which point we can take a tissue sample from their brain, look at it under a microscope, and get a better sense of whether plaques and tangles are in the brain. Now, of course, as I mentioned earlier, there is a certain percentage of people who have clinical symptoms of Alzheimer's dementia, but then when you look at their brain under a microscope after they're dead, you don't see an unusually elevated amyloid and tau deposition. And there are other people who maybe never have symptoms of dementia, and then on postmortem, their brain is riddled with plaques and tangles. So these biomarkers, they are, as I mentioned, they're fairly imprecise. There was another series of questions about incidence and prevalence, and those are good questions as well, because it does appear that the prevalence of Alzheimer's disease and the incidence, so incidence is the number of new cases, prevalence is the overall number of cases in the population, and both of those numbers appear to have been going down very, very slightly in the last 3 years or so. And that may be because we are starting to get better and more aggressive at treating a variety of the other modifiable risk factors for developing Alzheimer's dementia. So you may have heard that what's good for your heart is what's good for your brain. So as we've developed better treatments for heart disease, cardiovascular disease, hypertension, diabetes, as we've been able to treat those chronic conditions more effectively and more aggressively, then the cascading benefit of that could be a reduction in people's risk for developing Alzheimer's disease and Alzheimer's dementia. Somebody else also asked a really good question about long COVID. So you may have heard news that came out in the last couple of years that there's been some preliminary findings that people who have had COVID appear to be at greater risk for developing Alzheimer's dementia. We don't know for sure whether that's true, and we don't know for sure yet why that might be. So a lot of questions around long COVID and its effects on the brain. I also mentioned that there is in the diagnostic continuum or disease continuum, there is this concept called mild cognitive impairment, or MCI, which is the beginnings of the signs of Alzheimer's disease, so changes in the brain, but very, very mild clinical symptoms. Some people with MCI go on to develop full-blown Alzheimer's dementia, but not everybody with MCI. The prevalence of MCI is thought to be around 12 to 18% for people who are over age 60. But the prevalence of MCI is also lower at younger age groups and higher at older age groups. So only around 6 to 7% among 60-year-olds, but as high as 25% among 80-year-olds. So just like age is a risk factor for Alzheimer's disease and Alzheimer's dementia, so it is for mild cognitive impairment. Lastly, I want to spend a little bit of time talking about prevention. So there is a converging amount of evidence that suggests that certain lifestyle interventions may offer some sort of protective benefits for people against developing cognitive impairment, cognitive deficits. And one of those elements, one of the elements that appears to be effective is a certain nutritional profile. Mediterranean diet is probably the best example and one of the most well-researched nutritional interventions. And I agree with one of our participants that nutritional analysis should probably be a very, very standard component when evaluating older adults who may have some concerns about cognitive impairment. So that diet, which is slanted towards plants, high in nuts, fruits, and vegetables, combined with a decent level of physical exercise incorporated in a person's daily life, that those appear to be protective factors. So the more that we're able to promote those kinds of protective behaviors, the better in terms of making sure that people are moving into the later end of the lifespan with the healthiest brain possible. Now, you may have heard that there is one protocol that's being shopped around pretty aggressively now called the Bredesen protocol, or the RECODE protocol. This is a medical professional who has been studying a variety of individually tailored interventions based upon a person's metabolism, their lifestyle, and they issue a very highly personalized protocol that an individual can follow. And they have been promoting this protocol as one that can prevent or reverse dementia. The science around this is very, very preliminary, and there have been some very scathing, I would say, editorials about this protocol because the science is relatively weak. Details about how the protocol was implemented haven't been publicized and the people who are behind the protocol charge people for it. So it's not as if they're giving out this information freely to the public. But having said that, the science is suggesting that there are a number of possible avenues for intervention that which might be very effective at preventing. The trick is that we're going to need to start these things early. These are not interventions. We're talking about computerized brain training, nutritional interventions, exercise interventions. They're going to be good for people regardless of their age. But if there's already been damage in the brain because of the deposition of amyloid and tau, that's not going to come back. These are interventions that are not going to reverse that kind of neuropathological change in the brain. So if we're going to reap the benefits of exercise, sleep, good nutrition, social engagement, higher education, complex leisure activities and work environments, we need to start those things at a much earlier age for them to be beneficial, which is why many of the prevention trials are actually recruiting people in their 20s and their 30s and their 40s and planning to follow them for decades to see if these kinds of interventions make a difference at the population level. So thanks for these great questions. It's been a pleasure for me to get a chance to share some of this information with you. I hope you've learned a little bit this afternoon, and we'll see you for the next program.